If you look at almost any traditional industry throughout history, the barrier to entry is, well, it's entirely physical and usually entirely financial, right?
Oh, absolutely.
Like if you want to build a skyscraper, you have to buy thousands of tons of steel before you ever pour, a single ounce of concrete.
Yeah, you're locked in from day one.
Exactly. Or if you want to open a restaurant, you're paying rent on a dining room, you're buying tables, hiring staff months before a single customer ever sits down to look at a menu.
Long before you make a single dime.
Right. Well, welcome to the deep dive. Today we are looking at a stack of sources, architectural blueprints, startup case studies, and this fascinating thought experiment we found called AWS Architect for a Day, bootstrapping the lean startup.
Which is such a fun concept.
It really is. So you, the listener, are going to step directly into the shoes of a founder today. I want you to imagine you and two friends are like sitting at a kitchen table. You have this brilliant idea for a tech company, and you want to launch it today.
Right.
Right now. You're a tiny 3-person startup. Your mission is to launch an enterprise-grade web application. But here are the incredibly strict constraints of our scenario.
This is the best part.
Yeah. You must do it with absolutely zero upfront cost. You must have built-in auto-scaling to handle any amount of traffic, and this is the kicker, you absolutely must have a fully functional database.
Yeah, and the most compelling part of this entire scenario is the rule book that comes attached to it.
Yeah.
Because we aren't just designing like a theoretical abstract system here.
Right, it's not just a thought experiment for the sake of it.
Exactly. We have to map out these step-by-step service decisions in plain English. And the absolute strictest rule here is that we must rely on no assumed knowledge beyond the foundational AWS CLF C02 level.
Okay, so for anyone mapping this out, what exactly does that mean?
So CLF C02 is the exam code for the AWS Certified Cloud Practitioner. It is literally the ground floor.
The absolute basic.
All right, it means we cannot rely on niche, highly specialized coding frameworks or, deep network engineering tricks. We have to use the fundamental building blocks of the cloud.
Okay, so we are building a massive digital skyscraper, essentially. But our budget on day one is literally $0.
Zero.
Which is wild. In the physical world, taking that kind of colossal financial gamble on a prediction is terrifying. I mean, you're buying the entire house before you even know if anyone wants to live in the neighborhood.
Yeah, it's a huge risk.
So how does a team of just 3 people even begin to build an enterprise-grade app with literally no money down?
They do it by exploiting the fundamental shift from CapEx to OpEx.
Okay, break that down first.
Sure. So traditional tech companies used to start with massive CapEx, which is capital expenditure. Launching a web app in, say, the late 90s meant securing venture capital just to buy physical hardware.
Right, the actual serverics.
Yeah, you had to order servers, rent space in a data center, pay for massive air conditioning units, and hire a team to wire them all together.
All before anyone even knew your website existed.
Exactly. All of that happened before a single user typed in your URL. But what this scenario demands is a pure OpEx operational expenditure model. You're essentially renting microscopic fractions of computing power strictly on demand.
I love the theory of that. But let's talk about the physical reality for a second, because isn't demanding zero upfront cost for a tech startup kind of like, I don't know, trying to open a commercial bakery, but refusing to pay for an oven until the exact second a customer walks in and orders a croissant?
Right.
Like, how does the infrastructure even exist if you haven't paid for it to be built?
That's a great analogy, actually. The bakery analogy is a good starting point.
Okay.
Well, let's upgrade it to how modern cloud architecture actually operates.
Okay.
It's less like an oven and more like a global ride-sharing algorithm.
Oh, interesting.
Yeah, so the cars, which are the servers, are already out there on the road, engines running, owned and maintained by Amazon.
All right.
When a customer walks in and clicks on your web app, you are dynamically hailing a tiny fraction of that compute power for just the millisecond it takes to process their specific request.
So it's already running. You're just grabbing a seat.
Exactly.
Yeah.
In the foundational AWS vocabulary, we're talking about services like Amazon EC2, which is Elastic Compute Cloud. You spin up a virtual machine, use it to process a request, and then you shut it down.
Okay.
You only pay for the exact seconds that virtual engine was running for your user.
But there has to be a catch there, right? Because if I'm hailing a ride only when I need it, I have to wait for the car to arrive.
Right.
If our 3-person startup refuses to pay for idle servers just sitting around waiting for traffic, doesn't that introduce, like, latency.
Uh,
If I'm a user and I click on this app and the system suddenly has to wake up an EC2 instance or, a serverless Lambda function from a dead stop, I'm going to feel that delay, aren't I?
you absolutely are. You are touching on a critical architectural tension here.
Yeah.
Yes, in a purely serverless or a scale-to-zero environment, you encounter what we call cold starts.
Cold starts. Okay.
Right. When a request comes in and there's no active compute instance ready to handle it, the cloud provider has to provision the environment, load your code, and execute it.
Which takes time.
Exactly. That might add, say, a second or two of latency to that initial user's experience. But we have to remember the primary constraint of our scenario here.
Right. Zero upfront cost for a bootstrapping team.
Exactly.
So a 2-second delay for the first user of the day is kind of a small price to pay to avoid a $5,000 monthly server bill when you have zero revenue.
Precisely. The cold start is the acceptable trade-off for survival. If 0 people visit your startup's website on a Tuesday afternoon, your active compute is 0, and your bill for that afternoon is exactly $0.
Wow.
You are trading a slight performance hit on the absolute margins for complete financial runway.
Which brings us to the second major constraint, which is really the flip side of that coin, auto-scaling.
Right.
Because if the first rule is zero upfront cost, the second rule is that if 1 million people suddenly show up, the app cannot crash. It has to automatically grow.
Yep.
We aren't buying the cars, but what happens when 10,000 people need a ride at the exact same time?
This is where we have to define how auto-scaling actually functions under the hood.
Right.
Because that isn't magic, right? It's a deeply mechanical process driven by metrics.
Okay.
In AWS, there is a foundational service called Amazon CloudWatch. Think of CloudWatch as the central nervous system of your application.
Nervous system.
Yeah, it's constantly monitoring the vital signs of your resources, things like CPU utilization or network traffic.
So it's actively watching the EC2 instances we currently have running.
Yes. So our 3-person team sets up what's called an auto-scaling group. They define a threshold. They tell CloudWatch, hey, if the average CPU utilization of our active servers hits 70% for a sustained period of, say, 5 minutes, trigger a policy to launch 3 more instances.
Oh, I see.
So as traffic spikes, the system dynamically hails more rides to handle the load, ensuring the application remains responsive.
And it just keeps checking that metric.
Exactly. And more importantly, they define the scale-in policy. When CPU drops below 30%, terminate those extra instances.
Which saves the money.
Right. Scaling down gracefully is the only way to maintain that shoestring budget.
I hear the mechanics of that, and it makes sense, but frankly, this is where auto-scaling sounds like a massive liability.
How so?
Well, if our scenario dictates auto-scaling to handle whatever traffic comes, doesn't infinite scaling essentially mean the risk of an infinite bill?
Yes.
Like, if the app automatically provisions more compute every time someone clicks, and a malicious bot network decides to hammer our app with 1 billion fake requests overnight, couldn't our 3-person team wake up to a massive invoice that just bankrupts the company?
It's the ultimate paradox of the cloud, isn't it? Infinite power means infinite liability if you lag boundaries.
Right.
But this is exactly why the scenario forces the team to act as architect for a day. Foundational CLFC02 knowledge teaches you that an auto-scaling group is never, ever just left open-ended.
Oh.
You always define 3 things: the minimum, the desired, and the absolute maximum capacity.
So you enforce a hard ceiling on the architecture.
You have to. You essentially tell the cloud, scale up as needed to meet demand, but under no circumstances should you ever exceed 10 active servers.
That makes sense.
And additionally, foundational cloud management involves setting up aggressive billing alarms. You configure the system to send an emergency alert directly to the founders' phones the absolute second the projected monthly spend crosses, say, $50.
But let's play out that scenario for a second. Let's say we set a hard cap to protect our bank accounts.
Okay.
The app actually goes viral. Real users, not bots. Real traffic.
The dream.
Right. We hit our maximum server limit, the traffic keeps pouring in, and the servers are just maxed out. Does the app just crash for everyone else?
It does.
Wow.
Yeah. Requests start getting dropped, users get error pages, and performance heavily degrades. And that is a brutal, very real decision for a lean startup founder.
I can imagine.
Do you maintain the strict budget cap to protect your personal finances? Or do you log in, raise the maximum capacity limit, and just hope the sudden influx of users brings enough revenue to cover the skyrocketing infrastructure bill.
That is terrifying.
It is. The architecture gives you the levers to pull, but ultimately the founders still have to make the business decisions.
That is a fascinating reality check. Okay, so we have our zero-cost scale-to-zero compute foundation, and we have our safety rails on the auto-scaling so we don't accidentally bankrupt ourselves. But now we have to tackle what I think is the hardest part of this scenario, adding the database layer to the blueprint.
Yes.
Because a web app isn't just serving static HTML, right? It's processing transactions, remembering user profiles, storing data. If the compute instances are constantly winking in and out of existence to save money, where does the user's data actually go?
That is the exact architectural friction point that trips up almost all new teams. Hosting the static front end of a website is incredibly cheap and easy.
Right.
You can put your HTML and images in an Amazon S3 bucket simple storage service and serve it globally for pennies. S3 has no servers for you to manage.
Just sitting there.
Exactly. But a database is where state lives. Historically, relational databases, like a traditional SQL server, require a massive, persistent connection.
Yeah.
You had to buy a machine powerful enough to handle your peak load, and it had to stay on 2 and 47, even if it's at idle 90% of the time.
Which completely violates our zero upfront cost rule. So how do you provision a database in the cloud without paying a massive monthly fee just to keep the lights on?
This constraint forces our architect for a day to move away from traditional relational database servers entirely and look at cloud-native, serverless data storage.
Okay, serverless data.
In the foundational AWS tier, the prime example of this is Amazon DynamoDB.
Okay, now we are getting into the actual services. How does DynamoDB solve that idle cost problem?
So DynamoDB is a NoSQL database that can operate in an on-demand capacity mode. You do not provision a database server at all.
At all?
None. You do not allocate a certain amount of RAM or CPU for your database. You simply create a table, and AWS manages all the underlying infrastructure.
That sounds almost too easy.
Well, in plain English, you pay strictly for the exact megabytes of data stored, and you pay a tiny, tiny fraction of a cent for every individual read or write request your application makes to that table.
Oh, I see. So if our compute layer has scaled down to zero because it's a Tuesday afternoon and there is no traffic, there are no read or write requests hitting the database either.
Exactly.
Wow.
The table exists. The data is safely stored across multiple availability zones. But your cost for database compute drops entirely to zero.
That's incredible.
And when traffic spikes, DynamoDB inherently scales horizontally to handle thousands of requests per second without the founders needing to manually add database nodes or, manage complex connection pooling. The database is entirely HTTP-driven, which makes it the perfect stateless companion for compute instances that are constantly scaling up and down.
Okay, I understand how that works mechanically. But I do want to push back on the business implications of that choice for a minute.
Sure.
If we rely entirely on DynamoDB and S3 simply because they perfectly fit this plain English zero-cost criteria, aren't we walking straight into a vendor lock-in trap?
No.
Like, by building an architecture so deeply tethered to specific proprietary Amazon services, aren't we guaranteeing that this three-person startup can never leave the AWS ecosystem?
That's the classic argument, yeah.
Because what happens if Amazon decides to just triple their prices next year?
Right. Vendor lock-in is the absolute boogeyman of cloud architecture, and you will hear enterprise engineers debate it endlessly. But we have to look at the context of our sources here.
Okay.
We are bootstrapping a lean three-person startup. The trade-off you are making is between hypothetical future portability and actual present-day survival.
Okay, explain that trade-off. Why shouldn't a startup care about portability from day one?
Because building a completely cloud-agnostic architecture, one that you could seamlessly pick up and move to Microsoft Azure or Google Cloud tomorrow, requires an immense amount of upfront engineering.
Right.
You have to build custom abstraction layers, containerize every single component, manage your own database clusters. That takes time, money, and highly specialized engineers. Our three-person team has none of those.
Good point.
For a bootstrap startup, speed to market is vastly more important than multi-cloud portability. If you survive long enough for vendor lock-in to actually become a financial problem, congratulations. Your startup is a massive success, and you now have the revenue to afford engineers to refactor the architecture.
That is a very pragmatic way of looking at it. Survival first, elegance later.
Exactly.
And I guess this brings us directly to the core philosophy of our source material. which insists that every single decision must be made using plain English
Okay.
and no assumed knowledge beyond that foundational CLFC Euro 2 level.
Yes.
No advanced coding, no deep technical jargon. I know you view this limitation as a strength, but is a basic architecture really robust enough? I'm sure there are engineers listening right now thinking we're literally just building a toy app.
Oh, it's a very common reaction. There is this deeply ingrained belief in the tech industry that complex problems require complex solutions.
Right.
You will see teams of 3 people debating whether they should implement Kubernetes clusters, event-driven microservices, and multi-region active deployments on day one.
We actually call that resume-driven development.
Yes.
People want to use the newest, most complex tools because it looks great on a LinkedIn profile, not because the business actually needs it to function.
Precisely.
Mm-hmm.
Complex jargon very often masks inefficient architecture. The architect for a day scenario proves that forcing a team to stick to plain English and foundational concepts prevents them from over-engineering their application with niche technologies that they just do not have the manpower to manage.
Makes sense.
The foundational building blocks we've discussed, S3 for static hosting, EC2 instances in an auto-scaling group for compute, DynamoDB for a serverless database, and CloudWatch for metrics. These are not toys.
Right.
These exact same services, configured in these exact same ways, serve as the backbone for massive, globally recognized companies.
So simplicity doesn't actually mean fragile, it just means understandable.
In many ways, simplicity means resilience. When you force a team to explain their architecture in plain English, it forces true comprehension.
Ooh, I like that.
If you cannot explain how your front end communicates with your compute layer and how your compute layer handles database connections in simple terms, you don't actually understand your system. And if you don't understand it, you cannot troubleshoot it when something inevitably breaks at 3:20 a.m. Foundational architecture allows a tiny team to maintain operational control.
Let's take a step back and synthesize everything we've mapped out today. Because our mission was to unpack this thought experiment and see if a tiny 3-person team could act as an AWS architect for a day to bootstrap a lean startup under extreme constraints.
Right.
And what our sources have proven is that the modern technological landscape has completely decoupled physical infrastructure from the creative process.
Completely.
By utilizing fundamental cloud concepts, shifting from CapEx to OpEx, leveraging auto-scaling groups linked to CloudWatch metrics, and utilizing serverless on-demand databases like DynamoDB, you can actually launch an enterprise-grade application with $0 down.
Yeah, and the broader implication here is really the total democratization to creation.
Yeah.
You no longer need a massive venture capital check just to buy the right to build. You don't need to purchase physical hardware, and you don't need a PhD in computer science to bring a highly scalable idea to life.
Right, the gatekeepers are kind of gone.
Exactly. The tools to build something capable of reaching millions of people are fundamentally accessible to anyone willing to learn the basic vocabulary of the cloud. The global infrastructure is already built, sitting there, just waiting for you to hail a ride.
Which brings us right back to where we started. We talked about how building a skyscraper or opening a restaurant required you to buy the steel and pay the rent before you even knew if your idea was actually good.
Yeah.
The physical world demands this massive, paralyzing financial gamble. But in the digital world, that historical barrier is entirely gone. The infrastructure scales with you, and you only pay for the exact millisecond you use.
It's amazing.
It really is. So I want to leave you with a final thought to mull over today. If the modern cloud architecture completely handles the scaling, the stateful data storage, and all of the prohibitive upfront costs, doesn't that mean the only real barrier to entry left in the startup world is the quality of your idea? If the technology is no longer the hurdle, what is actually stopping you from building?